I want to get this started, but actually I have like example. Steal it from another project. Oh yeah, I put it in there. Okay. So I think I have this, and we want both of these things. Okay, so we do have optics. We have the KSP thing. Okay, but we don't have the actual idea set up, so we just need that. So this has like this extra bit of code here, which makes my life easier. So I don't have to deal with that stuff. And then I think all I have to do is add idea here. And then I should be able to relaunch this, and I think I will be good. Okay. So, I was going to do this differently. Why is it saying... Oh, it's saying that I have a typo. Okay, I was going to do this project slightly differently, but then I decided that I would like... I would be really bored with the project that I suggested to myself, and so I want to do this in a different way. So that's what I'm going to do. Here's our Gradle project, apparently, but it seems to be complaining, so I'm kind of unsure why. What if we just run this one? We're gonna have to warm up the JVM anyway. Done with this. What's this complaining about? Okay. So is there a... Okay, this font is too big for this, so let me fix the go down a little bit in the editor. So editor font. I was doing another video, and so this is just like straight up way too big. Okay, hopefully this is readable. If it's not, just let me know. Okay. So yeah, I have this this application set up that's a KTOR app, and what I decided to do is to change what I was going to do. I don't want to build... Okay, we can fix this stuff later, I guess. It's probably not a big deal. I'm not deploying any of this stuff. We're gonna have to update it over time anyway. Okay, so I want to implement this game. So let me discuss the game a little bit, and then we can like go back to the code. Okay, so the game is called Cat in the Box. It's by Bezier Games. Sorry, it's not. There it goes. I had it for a second. There it goes. Quantum trick taking game, Cat in the Box. You can play with 2 to 5 players, and the game design's a little bit different for 2 players and 5 players. The basic idea is there's this board. So on the board, you are going to fill in these numbers 1 through essentially 9, depending on how many players you have. And you have a deck of cards that you're playing with, and they basically have the numbers 1 through 9. There's 5 of each card. Okay. When you're playing with 2 players, you only use the numbers 1 through 5, just because there's too many spaces on the board. It's a trick-taking game, but as you note, all these cards are the same color. Okay, so the the interesting part about this game is that you don't pick the suit or color of the card until you play it. And so there's these boards where you play against them, and for sorry, it's not, it's like paying attention to my face and not the thing. So I guess I could just hold it back here. So the card number is basically, or the color, you play it on the side of the board depending on what color you want. And so that is basically how the game works. There's a 2 and 3 side. Sorry, it's going to be really hard to see, but it's down here, 2 and 3, or a 4 and 5 side. And so there's also betting in the game, but we kind of haven't got there yet. Okay, so let's say I have this card in my hand and I want to play it, and I want to play it in the blue color. I will say I want to play this as blue, and then I will basically put a little marker in the blue 3 right there. Okay, and then that means that no one else can play a blue 3 for the remainder of the game. So that's like how the game kind of works. Very short and sweet. Now, on this board here, you can see these little X's. So for each of these X's, you're going to have these tokens that sit on top of them. And basically, if you have a token on top of the X, so let's say I only have a token on top of this yellow, that means the only color I'm allowed to play is yellow. And when you break suit, if you've never played a trick-taking game, there's almost always breaking of suits. That will mean that you'll lose the ability to play that color. So let's say somebody starts with yellow, and you currently have, I don't know, let's say markers on red and yellow, and somebody started with yellow. Yellow is called the lead color, and then you have the choice to break the suit whenever you want. The consequence for breaking the suit is you lose the ability to play the lead suit. So let's say person leads with a yellow, you play a red card because you have a marker on red, then you lose the ability to play yellow for the rest of the game. So that's basically how breaking works. And if you've never played a trick-taking game, there's also a trump suit. In this case, the trump suit is red, and red basically beats all other cards. So to like score, I guess I should explain one more thing. There's the concept of a round and a trick. So a round is you playing all of your cards. So almost in almost all of games that are this way, you deal out like an entire set of cards. In a 2-player game, you have to remove some because there's, again, I said there's 25 cards in the deck. So you actually like, you burn 5 cards and then you deal the rest of them out. So a round is you playing every card in your hand except for one, as it turns out. Usually you play all your cards. It just depends on the game, obviously. And then that's like the entire round, and the whole round is built up from tricks. A trick is you playing one card from your hand, and everybody who you're playing with playing one card from their hand, and you have to follow the rules. So the rules are, as I said before, like you have to have one of these things covered. So if I have these two covered and green and red are uncovered, I can only play suits yellow and blue. So that's the first rule. The second rule is that space needs to be open on the board. So if you only have 2 of blue, like let's say you only have a 2 in your hand and these 2 are covered, so you can't play red or green, so all the 2s are played for you. You form what's called a paradox, and a paradox will end the round automatically. So paradoxes are cool. We were actually playing the game incorrectly yesterday, and that was causing some issues. So yeah, and then at the end of the game, you basically score based on your tricks. So in a 2-player game, there are no bids. It's basically you get points for every trick, unless you cause a paradox, and then you get -1 point for each of your tricks. And if you score more than 4 tricks, so 5 or more, you end up with you don't get what are called bonus points. The way bonus points work are like, let's say you had all the ones for some reason. So you have these player tokens that you've put on top of all the ones. Since you have those, and I don't know, let's say the opponent has all the 2s, and this is your longest sequential row of things, you get a point for each of those as bonus points. Again, if you score correctly. So in 3 through 5 player games on these boards, you have to bid at how many points you're going to win, how many tricks. So you could win 1 trick, uh 3 tricks or 4 tricks in a 3-player game, or in a 4 and 5-player game it's 1, 2, and 3. So if you guess the correct number of tricks to win, that is how you get bonus points. So if you don't hit your number, you just don't get bonus points. Yeah. So that's how that works. Okay, so that's like the game in a nutshell. Like really quickly, obviously. And so we're gonna try to implement that. So I'm gonna start. I've never implemented a game before, but we're gonna start with like wait, that's not what I wanted to do. I want to create a new, yeah, we're going to create a new column file that's going to be cat in the box. I don't know what we're going to call this yet, but it's going to be part of our models, and it's going to be the game cat in the box. The other stuff that I have in here is basically just an example of me screwing around with ktor and exposed. So at some point we'll use exposed to like keep track of everything. Yeah, so we'll see how this goes. So I think like the first thing I want to do is basically just create an enum class that is like colors, or color probably. And so there is red, there is blue. Is this how you do it? I think you do it like this. Blue, green, and yellow. Do I have to do it like this, or can I like do lowercase? Looks like I can do this. Okay. And then as I mentioned before, there's like a color. A fun color is Trump. And this is basically just this dot so to determine if something is a Trump color, it's just whether or not it's red. So that's like scoring. And then we have basically the available cards. So there's like an enum class cards, I guess, where we have like 1, 2, 3, 4, 5, 6, 7, 8, and 9. So those are all the possible cards. And then basically there's the ability to order these things. So I wonder if we can just derive or like orderings from these things. Let's see. So derive order Kotlin in ordering. Comparable? Are enum classes comparable? Let's find out. So let's say we have higher. It shouldn't be plural, it should be singular. Okay, so this is basically this dot card, or no, this is less than other. So this seems to be allowed, but like, what does this mean? I'm guessing this is okay. Okay, anyway, we can deal with this later. So those are all the cards in the deck, 1 through 9. And then, oops, I keep doing this. And then, what do we want to build next? I guess, like, there's sort of, like, variations of the game depending on what's going on. So there's kind of, like, some concept of bidding. So, I think that's going to be a sealed class. Because for 2... like, maybe I want to be flexible enough to say how many So I think we're gonna make a sealed class called I don't know. Let's start with this. Players. So game size. Okay. So that's like the size of the game. Depending on the type of game, then we're basically going to have to deal with that. And then I think like the rest of the stuff, or maybe the game size is like an interface. So it's like determining all the aspects of the game is like an interface, because the board changes depending on the game size, and the sort of player board, this thing changes depending on the game size. So maybe there's like an interface that's called like game. I don't know how to do interfaces exactly. So interface Kotlin. See how these look. Yeah, there's like functions and properties. Yes. Okay, so the game has a like number of players, which is an integer. It has like whether or not there's bidding. So in a 2-player game, there is no bidding. Or maybe like what we want to do is say bid types or something. So maybe there's a sealed class called bid. Bids? Bid? I don't know. Not like that. And there's an object called no bidding. And then there's like 134. I guess this can just be an enum class because I don't really need it to contain anything. One, three, four, and 1, 2, 3. So these are like the bidding options. I don't really want to write this yet. We're just like writing the pure code to like see how this ends up working. So it's like the bid style, or the bid is just a bid. Okay, so that's that. And then every individual player is going to have their own board. So there's like going to be a game state, data class, game state, I guess. And that thing is going to have a few things. It needs to have a board. It's like the current board. It's called a research board. And maybe we'll build a research board type in a second. just like putting something in here. Why does it do that? I wish it didn't do that. We're probably gonna want optics on this. No. Go there, I guess. Okay. So a game will have a game state. I don't know, something like this. Okay, and it will... Oh, the game state will also need to have... the deck of cards. There's going to be a player state that's like the current hand. I don't know. Oh, that's not how you do lists in this language. Which is going to be a list of cards. You have like current bid. Okay, so there's a style of bidding, and that's like how the game is bid style. Okay, and the current bid is just a bid. But like this is potentially nullable because in a game of 2 players, there's no bidding, I guess. Okay, this feels like a little progress, I suppose. So then we need to describe your ability to like play, like your board state. Player board. So there's like the research board and the player board. The player board is essentially a map from color to bool, I guess. Boolean. So it's like it describes what colors are playable, and its default will be map of color red to true. Color, oh, I think it's lowercase. Blue to true. Color green to true, and color yellow to true. Okay, so the board always, your player board will always start with those three things, or those four things, and your ability to play those cards. Okay, so you have your current bid 1 3 4. You have your player board, which is you're starting there. So I think this is like, I think this is the player state. This can actually probably just default to null, because like in a 2-player game, you're just like not even going to be allowed to mess with the player state, I guess. We're probably going to want a companion object here so that we can make optics. Player to player state. So you have the ability to be 1 2 3 or 5, 3 4 or 5, right? And okay, yeah, something like this. Okay, so then there's probably some checks, like is valid player. It's going to take a player and return a boolean. Okay, so there's like some validity checks for each game. Is valid bid is going to take a bid. Okay, what else could we have? Like, maybe we want this. Like, we can always remove stuff. I'm just kind of like thinking out loud. So like, you know, depending on what kind of game you're playing, these things are valid. So maybe we have we have a bid style, so we know the bid style. But maybe we don't care about the bid style and we could just say is valid bid. Like we can just have the validity checks. I don't think we really need this. Okay, and then the other thing is like starting deck is gonna be a map from card to integer. I think it's just int. So it's like how many cards there are in the starting deck. And then we'll probably like shuffle them into the game state at some point. Yeah, something like this. We'll deal with that here in a second. But I want to start like trying to enumerate as much as I can think about, and go from there. All right. So let's try and like build one of these games and see. So instance, I don't know how to make an instance. Class. Okay. So a class 2-player game. is going to have number of players equals to 2. It's going to have the game state is something. We have to figure that out later. We'll leave that as to do. The player state is also going to be to do for now. But we know that like it can only have 2 players, obviously. So we should initialize the player states basically, and we'll have to initialize the game state as well in these things. The starting deck is actually something that we can do because this is going to be a map of so card dot 1 to 5, card dot 2 to 5, card dot 3 to 5. Okay. And then let's do these functions. Is valid player. So when so only 1 and 2 are valid players. Oh, I'm not done yet. Okay. So is valid bid. I don't really need is valid card because I have a starting deck probably. So so there's no such thing as a valid bid here. Although I think that literally can just get folded in. I don't think we need any of this. I think that's actually like not helpful more than I'm thinking about it. So like we have a starting deck and then like we just need to know the player state, which is going to contain a bid. And when we initialize the player state for a 2-player game, we'll just make the bid 4. Well, it's actually less than, it's 4 or less. I don't know. I don't know how to deal with that yet. But we can deal with the bids later. We don't have to do the bids now, I guess. Okay, let's see if we can build this player state. So what's the initial player state? Well, we need the research board first. I don't know that we need to separate these things. Let's see if we can do this. Okay, let's start with a research board. Delete. Oh, I have this here. Just use this. Okay. So what's a research board? So let me just show the picture again. The full research board is this. So it's basically like all the spots that you can play in. So it's basically a map of colors to numbers. So Oh, not like this. And then like depending on the game, you'll initialize the board differently. So if it's a color and a card, we may also want to have like a null, or potentially it's a map of pair, color, card, and a boolean. So this allows me to initialize the board with all the colors and numbers that I need to, and that way, and then they like contain something or nothing. So I think that that's actually probably a better research board. Yeah, probably. There's also like two different versions of the game, but we'll implement the white side first. Okay, so that's a research board. And then you have a deck of cards and a hand of cards. Okay. So what is a deck? A deck is this. So I don't think we need this deck here. I think that this is just a map of card to int. How many cards do you have in your hand? Oh, that's like, okay. Anyway. I don't think we need to say current. Okay. Okay, so let's see if we can do this. So, let's initialize the player state. So, we're gonna have a map of player.1 to map of, and then player.2 to map of. Yeah, it doesn't know what it is. Okay, so a player state. This is where we need to start like oh, the player state is not a map. I get it. Okay. So let's see if we can build this. So we can't deal with this. Maybe we should initialize the game state first. That might be easier actually. Let's put this back to do. The game state's easier because I need to like, I think I need to pull stuff from the game state. I'm not really sure yet. Again, I don't know what I'm doing, so we're learning. All right, so a game state is a research board, and so we need to build the research board. So we're gonna build the game state, and we're gonna build a research board, and we're gonna build, what's the other thing? The deck. I already have, oh, like here I guess I would take the starting deck and like shuffle it. I think I want this to be a list of card. I think that's probably better. So you can take the starting deck and then turn it into a shuffled list of cards or something. I think that's what we should do. So to do, this is what we're gonna do this next. Shuffle starting deck into list card. Okay. So the research board, I think, is, what do we decide? It's just a map of color and card to Boolean. Okay. So we're going to say map of, and then there's just going to be a lot of stuff here. So we're going to have color. So color dot red to 1 card dot 1 to false. Except I don't really want to write all of this. So I think I want to have a function that takes construct. It can't be it's got to be like make research board. We're going to have some colors, which is a list of color, and then we're going to have some numbers or cards, which is a list of card, and we're going to return a map what's the research board? Yeah, maybe we just make it an alias so we don't have this state thing. Do we gain anything from it being an alias? I mean, not really. But I think if we make research board... Oh, isn't there new types? I don't think it really matters, because this type is pretty weird. So I think you say map, pair, color, card, Boolean. Like this. And we don't really need optics for this thing. It can just be that. Okay, because we'll have optics for the game state, so we can just get the research board if we need it. Okay, so this is going to return a research board. I guess we could have just not really worried about that too much, but okay. So here we need to build the research board. So we're going to say like for color in colors, for card in cards, and here we're going to have like a mutable map, and then we'll just return it into this research board. So it'll be a mutable map of research board. Wait, can I do that? I don't think I can do that, but that's okay. So board, mutable map of these things. And then in theory, I can just return a board and it should be fine, because I think that it's smart enough. And if it's not, we'll like straight up do that. Okay, So then we can basically add to our board. So board color to card equals false. And that is how we build a research board. Okay, so our research board will be make research board, and we're gonna have a list of all the colors. I wonder if there's a way to say all the colors. I guess it's obvious that it's always all the colors, right? Let me double check. So um, there's two sides of the board. And okay, so there's a purple side of the board that it still has all the colors and the numbers 1 through 9. It just changes how many of them there are. Or it changes the shape of the board itself so that you can basically make the score a little more interesting. So I don't think we need to have the colors as an input. It will always be we really only need the cards. The colors will be list of color red, color blue, color yellow, color green. I wonder if there's a way to do that. Color dot val x equals color dot. Yeah, it's right here. Values. Nice. So I don't have to do all this. I could just do color dot values. Sweet. So that'll get me the board, and I'm pretty sure that this does the right thing. We can deal with that later, but then we can just make the board of numbers. So how many times am I going to need this? I don't know. So I'm card 1, card 2, card 3, card 4, card 5. I might also be able to say, like, let me see. So we could say card dot values dot filter it less than or equal to card dot 5. Yeah, okay, that's a little better. So you're basically saying, like, I want all the I want to make a research board of all the cards less than 5. That's a little easier to reason about for me. Okay. Unreachable code? What does that mean? Okay. Cool. So let's see. Is that the game state? I feel like turn is probably fine. Why is this unreachable? Is it because it says to do? I don't really understand. Okay, so anyway, let's see if we can figure out how to turn a starting deck. Well, we can just like make a function called shuffle. That's gonna take a starting deck, which is a map from card to int, and it's gonna return a list of card. Okay, now I don't know how to do random numbers. Shuffle, Kotlin. Okay, if you made an array, you could just shuffle it. Nice. Okay, so we want to say for this is probably gonna be like run. Whoops. For list is a list of a mutable list. Nope. Mutable list of card. And then we're going to add. What is this? I don't know what this does. So list. What does this give me? An entry. So there's a card dot key and a card dot value. Okay. So then we're going to say for so all we need to do is say list add card dot key. And then at the end of this, we'll just say list dot shuffled dot to list. I think this is redundant, but I'm not 100% sure. So what does it want me to do here? Okay, that's fine. Okay, so then we can just take our starting deck and shuffle it. So shuffle this dot starting deck. And that's our initial game state, I think. Let me just check my phone. Okay. It's my mom, but I can text her later. Okay, so that's like the initial game state. So we actually need to go through some steps from the initial game state to like set up the game. So we'll deal with that here in a little bit. But our starting deck was useful, I think, because then like our shuffle code works for every starting deck, which is nice. And we have finished our initial game state. Okay. And we've said that the first possible player is player 1, which is fine. All right, so let's think more carefully about the player state. I think what we should do is initialize this in the simplest possible way. and say like their hand is also empty to begin the game, and we'll shuffle out the cards when everyone's ready or something. So this can be list of nothing or empty list. What is it? Empty list. Uh, and like that way we can initialize the current player state a little easier, and then we'll have so this is probably fine. Okay, so the initial player state for a 2-player game is going to be like map of player 1 to player state like this. Player 2 to player state. Right? So we don't use those yet. We haven't used any bids yet because you can't bid in a 2-player game. And we've used color, but we don't care about the is trump card yet. We're gonna have to like have a concept of like a trick at some point, but we don't need that yet. Okay. I also think that this is still got to be called game state. Because it can vary, right? These aren't vowels. These are vars. The starting deck and the number of players can't change, but the game state and the player state can change. Okay. So these are going to be override var, override var. But why not? Okay. So now we need to initialize. So there's like the first step is like a setup step. So we want to implement a setup step, whoops, for the 2-player game. So in a 2-player game, you take the deck, you remove the first 5 cards. So that's what we're gonna do. We're gonna have a function that's like what is it called? Let's call it what they call it in the game. I think it's like preparation. So preparation. The preparation is basically just going to, that is preparation. It's a side effectful function that is going to basically populate the hands. So it's gonna take nothing and return unit. It's like a side effectful function. We could even mark it with suspend if we wanted to, even though I think it's not gonna complain that it's like not that way. Redundant return type. Okay. So we are going to prepare the game. So let's see if we can figure that out. So override fun preparation. Run fun preparation. Okay. So to prepare the game, we need to take the current game state, the research board from the game state, and we're going to basically deal the cards out. Okay. So we need to deal. Okay. So to deal the cards, um, we need to basically split them. So take a Kotlin list. I don't know. Okay, contains all get, index of, last index of, sublist, from index to index. I kind of like want to split it instead. Is there like the ability to split at? Split at? Okay, so partition. Is there a partition indexed? Partition indexed? Let's see. So, what is this? It returns a pair of lists. So, I don't know. Let's see if it works first of all. So this dot game state dot deck dot partition. No. There should be 25 cards in the deck. What does it take last maybe? Yeah. Okay. Okay. So something like this. So actually even this we don't really need to do because we're gonna empty the game state. So really we only need the first cards and then the last 20 cards, and then we can say game state dot deck dot modify. Maybe I just need to hit play here because the game state should have. Okay, so we're gonna modify the game state, and we want this to be empty list basically. So we're saying like you've dealt the cards basically, and then Okay, so we also need to populate the game board. So there's going to be some... Okay, I should write this down because I'm starting to get bogged down by details. So the first 3 cards populate the game board. So for example, 442 will populate green 4 and 2 and yellow 4. So it's like if you had the 3 the same card, it would do green, yellow, and blue. If you had 442, in this case, you would have green 4 and 2 and then yellow 4. So we may want some tests here. And then deal the rest of the cards to players. Okay, so then we can say this dot player state dot we can actually like chunk this chunked 10. So this will give me a list of lists, and then we can just like give the player 1 what's the player state? It's just a map of a player to a player state. I think what we want to do is deal them the card. It's kind of... Okay. Okay, so a player state has what? The current hand. Okay, so player state dot current hand dot modify this dot player state player 1 Okay, let's see why this doesn't compile. But the basic idea... Oh, actually, this doesn't work. It's going to be the player. That's like the current player. And then we're going to modify that player. Okay, let's see what's up with this. Okay, so this is like... We need the, okay, we need a map index, which I think is like at. So the optic that we want to make is map or at map of ba, 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 ba. It's a player state. And then the player. Okay, I gotta look at an example. So arrow optics, and I'm getting very hungry. I think it's at collections DSL at. So map. So this is an int to string, and we say dot at. Okay, so we build this, and then we say dot at player. Okay, so there's our optic. And then we can say this dot player state. We want to take the player state optic. Oh, I get it. Okay, so this gives me a player state. And then if I have a player state, I should have current hand. Okay, so we have map at dot set. Okay, so we're gonna have optic dot modify, and we want to modify the player state, and then we're gonna say a player state dot current hand dot modify it and what we want to do with it. So we want to give them the cards to deal from the index, I think. Or empty. Well, the whole thing is null. So, okay. Okay. So you have a player state, and then if I just put it here. Okay, so this doesn't work. Hmm. So this is an option. I don't really understand what this is doing then. Required. So what is this complaining about? Ah, okay. So this is the one that's the problem. So what do we want to do here? We can't really do anything here. 1 second. Okay. Let's just get the current. Okay. Let's val. Player state equals optic dot get this dot player state. Okay, then this thing is an option of that thing. So if we are able to find it, is some, yep, then we want to do something. Let me delete this for a second. I think it's not called none. I think it's none. Like this. Okay. So, if this is none, then we need to modify that player state. So this thing needs to return a next with dealt cards. So we're gonna take the player state and we're gonna mod. Oh wait, if it's none, then there's nothing we can do. Otherwise, we're going to take the player state and we're going to modify current and modify player state with the cards to deal index. Okay. And then now that we have the with dealt cards, we can put the player state back. Um Oh, this is the same problem, isn't it? Okay. 1 second. Okay. Sorry about that. I just have a headache. I think we need to change a bit of this because it's getting already really frustrating. Um, so mainly that uh our current hand needs to be a mutable list because we're gonna add and subtract cards and stuff. Ow. So let's do that because that'll save me a lot of time. Although I don't really want this. Do we want... I mean, it's got to be mutable at some point, right? So do we want... Yeah, this is fine. So, this simplifies things a lot, doesn't it? Because we just need to, like, change the... So we're going to say, okay, and then also the deck for the game state. The starting deck... Okay, and then this deck should be also a mutable list of card. Okay. What's... Well, we shouldn't make this. There's no reason to make this the mutable part. This is a pure function. So it's after we shuffle the cards that we want to say to mutable list. Okay, so this means that the GameState.deck can become empty mutable list of. Clear. Okay. Okay, now we can deal the cards. So for player in this game state, who are the players? Oh, it's okay. This dot player state dot keys. Once we finish dealing the cards, I think I'm gonna get off. I have a really bad headache right now. All of a sudden, you really should drink more water. Is what I should do. Okay, so now we're gonna say this dot player state of player, and then we're going to set equals and then oh right, and we're gonna say with, what did I just do? That with index, so we can take that cards to deal index. How do I change a map? Put. Course. Put. But I can't put it. Why? Probably because the player state is not mutable. I feel like this sucks, but also I don't know how to nest the optics such that it's easier to do. So maybe we'll fix this afterwards. I'm guessing that you can compose the optics. So you say like you get the optic at, and then you can compose the thing lower to it. So this is gonna put the player cards to deal index. Yeah, and then this is the same issue. It's like this. Yeah, you find this like nullable issue. Okay, let's do it a different way, maybe. So if we do this player state player let, and then current player state, and then do this. Okay. Nice. And then okay. So uh so we deal the cards to players, and now we can populate the game board. Okay, so we're gonna say for card in populate game board with this dot game state dot research board dot put so the research board. Yeah, we need to like make some functions here that are just like way better. So we're gonna have a function that's like fun populate research board, which is gonna return a new research board. See, these are like the kinds of functions that I need to build right now. And maybe we want to separate like research boards and other things into more easy to understand places. It's going to be okay. So we're going to give this thing a card, a single card. Okay. Now, this is like this this is like setting up the new research board. Okay, so this thing's a map. So we're basically going to we want to look up that card in the map in green specifically. So Okay, I got an idea. Um, does this compile? Required Boolean. Found card. What? Required pair color to card. Green to card. Okay, so if you find it, then we need to go further. Ugh. I hate this. Okay, so this is like a green optic. And like okay. So we want to basically modify like the first one that returns something. I wonder if there's a way to do that. I have no idea. Can we fold? Um get multiple results. I don't really know how to do what I want to do though. Because like if I get the green optic, so what's the return type of this? So if we have a val x, it's an option. So the research board will always have the thing. I think we can say I don't think I can do this. This is really annoying. Okay. I think we're just gonna have like a nasty when block and be done with it. Because I don't really know how else to do this. So if this is none, then we can put the thing. So we're gonna say basically green optic modify research board, it becomes true. Why is it an option? I think you just say some. But why? Why does this need to be some? What's a research board? Oh, we can test this thing later. Is some. Then we go into the yellow optic. So like when we're programming with pure data types, I think that you can have situations like this, and there's really not much we can do about it. I don't know how to say like how I would match like in this triple, like is none is some. It's like I don't think I can do. I mean, we can try. So if I do like, let's just try doing two of these things. So if I do this one and then this one, let's say, and we just make it a pair just to see what happens. Can I do like is none to is none? Like how would that work? Like I don't think there's a way to do that. Like you see what I mean? Like there's just maybe I can do commas and then like this. Yeah, see, like I don't know how to do this. I think you have to say is but as far as I know, there's no way to say. Oh, we could say get or null maybe. But this is just going to chain these things in potentially an ugly way, but let's see what this looks like. Because this is just going to be like... You see what I mean? Like, I don't think this is any better. Okay, maybe there's a different way we can do this. Maybe we can say list of yeah, we basically need to work on a bunch of these kinds of functions to make this less mutable, because it's going to be a nightmare if it's as mutable as it was. Okay, so we have a list. And we basically want to know the first. Where you have this pair. And we want to say p.second.get research board. we want to know when the first one is none. Okay, let's do that. Okay, I think this is actually better. So index, let's say pair. Okay, and then if we find the first one that's none, there's basically two options. I think this thing returns... first or null. And then that's like a nullable pair. Right? And then I think we could say if, or like, yeah, if pair is null, throw, error, jacked. We'll fix this later. Else, we return the final thing, which is the error dot second dot modify the research board. We want to set it to true dot sum, apparently. Yeah, that's kind of fine, I guess. I think that's better. Like, the first one that we get that's none. So, basically, the piece that I didn't tell you is, when we're initializing the board in a two-player game, you basically have... Let me set it up real quick. So you basically have the numbers 1 through 5 in a two-player game, like this board here. And then what it's going to do is you're going to draw 3 cards and fill in green, yellow, or blue of those things. So let's say we draw 3, 3, 3. Then you're going to fill with like unused tokens 3, 3, 3. And if you get 3 different numbers, let's say 1, 2, 3, then you would fill up these with like something. So that's basically what we're doing right now, is we're saying that these are filled. Now, one thing you can see here is there's like a problem with our board, because these really need to be like some player, and we need to fill them with a particular player. Okay, so there's some to-dos in here which I want to write up. So first is like we need to split out research board into package module. I don't know, something like that. To do the research board can't take a boolean. It needs to take like player, a nullable player. So if it's null, it's unplayed. Otherwise, it's a player. And so in the case of like a 2-player game, you would prepare this board with a certain player that's not playing the game. So it could just be player 5 in this case. Because we want to know who who played. Okay, so this is not gonna work. Remove mutable. To do. Remove mutable. To do. Remove mutable. I need these things to be pure. Otherwise, they're just going to be a real huge pain in my butt. Okay, so what's complaining now? There's like one error. Oh, okay. So then here we can just create the new board and return it. So the research board is now going to be prepare research board. The current research board, this game state research board, and then the card. This is a val. So, okay, so what is the research board? Yeah, see, like, this is kind of one of those things where it's like we need to we want to return a new research board, but this does need to be like a var, or I can't change it. It's if I don't make it mutable map, then I have to like modify it the right way. So I guess that's something. So anyway, I think this is really what I want. Like we want to have non-mutable maps, but vars, so that we have to have pure functions modifying the game state. That's kind of like what we want. Okay, anyway, that's all I want to do today. I think that like this should at least compile now. Where? The current hand. Okay, does this compile now? Yes. So like there's some stuff here that I don't love. Like this thing here should basically be a function like deal, and it should deal the cards to the player and return a new state, so that it's not like this mutable map stuff. We should take a map and return a map. So just like this. And that way these functions here are pure and more testable, whereas this is like really impure and untestable, because there's just no way to do that. So we have to fix this. So to do this should be a function that takes a state and returns a state. Okay. We'll have to see if that's possible. Like this is kind of like the same thing. It's like take a state and return a state. Okay. We're still learning, so yeah, this will be unused. But anyway, we're making progress. We have a lot of the board kind of set up, and now we're kind of like initializing the first stage of the game, and then we can do, you know, like rounds and tricks and these sorts of things. So we'll get there. Okay, thanks for hanging out, watching if you did. Otherwise,